So how exactly do we generate these RS assignments? There's a systematic approach that you want to take, and we're going to do this by working with the example here on the right. And our first step is just identify the 4 atoms that are directly attached to the chiral center. So in this molecule, here's our chiral center, and we want to identify the 4 atoms directly attached. We have a hydrogen, a chlorine, a bromine, and a carbon directly attached to the chiral center. Our next step is to prioritize these atoms, and we prioritize them by the atomic number. So we'll have to use the periodic table to help us out here, and we're going to give the number 1 priority to the highest atomic numbered atom, and then we'll go 2, 3, and 4 to the lowest atomic numbered atom. Let's bring up the periodic table here for just a minute to help us out. And the atoms we're dealing with: hydrogen, carbon, bromine, and chlorine. And remember from general chemistry that we get our atomic numbers right from the periodic table. So hydrogen has an atomic number of 1, carbon 6, chlorine 17, and bromine 35. So based on that, of these atoms, the one with the highest atomic number is bromine. So we want to give bromine our top priority, priority 1. So I'm going to put a 1 by the bromine. Next is chlorine with an atomic number of 17. That's priority 2. Then comes carbon with an atomic number of 6. And finally, our lowest priority group is hydrogen, which is priority 4. If you have a hydrogen on your chiral center, it's always going to be your lowest priority group. Okay, our third step is that we have to rotate the molecule so the priority 4 group is in the back, meaning so it's on a dash. The easiest way I find to do this is by just finding a group to hold constant and then rotating the other 3 around. So the way I'm going to get this priority 4 group to the back is I'm going to hold the CH3 group constant in place, and the other 3 groups we can move around clockwise or counterclockwise. So what I'm going to do to get the hydrogen priority 4 to the back, I'm going to rotate it to here, the bromine out to the front, and the chlorine over here into the plane. When we do this, what you want to do is draw your main tetrahedron just like you have before. So I have my 2 bonds in the plane, my dash in the wedge. My methyl group, I'm leaving it right where it was because that's the one I held constant. But then my hydrogen was rotated to the back. The bromine was rotated out. And the chlorine rotated into the plane. Now let's just retranscribe our priority numbers. Here's priority 4, 1, 2, and 3. So now we have this set up the way we need it with the priority 4 group in the back. So for our final step, to get our RNS configuration, we have to draw a curved arrow from priority 1 to 2 to 3. If our arrow goes clockwise or to the right, we assign an R configuration. If our arrow goes counterclockwise or to the left, we assign an S configuration. So for this particular example, let's start and put our pencil down on priority 1. And I'm going to draw an arrow from 1 to 2 to 3. That arrow goes around counterclockwise or to the left. So that means this chiral center has an S configuration. And that's the basic steps we're going to follow for all of these examples. All right, we're going to see a few subtle points when you have some ties and things like that, but just follow these steps carefully in order and you'll be able to assign any of your RNS configurations.